everyone. By that time, the things get ready. So I hope you have settled after the tea. And I heard that tea helps to rise the dopamine level in our body. I don't know whether it's true or not. I have never experienced. But if it's true, so half of my job is done actually. So thanks if the organizing committee for arranging the conference on such important topic of recent times, that is the energy. And giving me the opportunity on behalf of FOET for share some of the insights that we deliver to our customer and customers are getting benefit from that. So back in 2015, when we internally assess that what saving potential digitalization can generate, we came up with an intriguing insights that 10% of operating cost can be saved through digitalizations. And it includes all kind of resources, as you can see, fiber, energy, materials, labor, maintenance cost. Specific to this subject of today's discussion, I will be touching only energy saving topics. Now, before going to the main subject, I touch upon what a digitalization journey means. So this is basically a steps which is followed to deploy any digitalized solution. It starts with, of course, measurement through sensor, which is installed at field. It has to be collected through a data historian, that is a data park from us. It has to be visualized, explore, and make it operationalized. Otherwise, this raw data cannot create a value. So to make it operationalize and utilize for further steps, that is advanced process modules or sometime MPC. So this is actually the real integration with existing plant or DCS scale, PLC. So till the measurement, now it is directly connected to DCS. We are trying to put another layer into it that generates the value, and we call that digitalized solutions. More or less, this is general steps for every industry, whoever taking care in digitalizations. So I will refer modules, and we call from FOET as on efficiency. This is our product name on digitalized platforms. I will touch upon this 4 topic where we have got significant energy savings. The first topic is on dewatering module, that is related to vacuum energy savings, vacuum being a higher energy consumer of a process plant. Then DIP modules, which is on a dinking plant, specific to a flotation cell area where the lot of recirculation is there in any flotation cell, as you know. So there is an energy saving potential we have got on the recirculation energy. I think my timer has not started somewhere. Now it's on. Okay. So then I will move to the strength module. Strength module is related to optimizing the application, which in turn leads to a less water in or after sizing. So it will help the steam energy savings in dryer sections. And last but not the least, which is most important topic, can we save brake? And brake saving means it's directly increase productions, improve productivity, and specific energy consumptions reductions. So with this, I'm moving to the first topic, dewatering module. On-control dewatering is our name. So think about a shop floor, what is happening in a wire sections. Operators are more or less settle the dry line or water line in wire sections, and then they are helpless without understanding its impact on final applied dryness. So dryness in real time is not available today. So we are here to help this module with dry or the ply dryness control through vacuums. Vacuums are nowadays more or less runs at constant level. Sometimes maybe some boxes or suction boxes they on and off, but vacuum more or less runs at constant set point. We try to fit in based on the ply dryness, end dryness, regulating the vacuum. So vacuums will be needed, whatever is just needed. So in that way, it will gives that this module actually helps in other way as well. Stable dryness, optimized ply bond at lower cost through saving energy on vacuum, because vacuum is now operated at what is just needed. Now, how it can be done in a machine itself? As you can see, it is an example of multi-layer board where the forming sense is a sensor, water weight measurement sensor calibrated and maintained by FOET. It will tell the dryness of web at each of the the layer end positions. And this is now available. So operators can see what is my dryness at end of each ply before combining position, and for a single layer machine is of course in couch. So with this, it is now, we are plugging it into vacuum system so that vacuum can be run at regulated manner. So we know the dryness, whatever be the intake fiber characteristics, deodoring characteristics, the vacuum will be regulated, auto self-regulating kind of things adjusted together. So now here, some of the field results I want to show you. As you can see, on your left, this is a situation without this module. And here, when the dryness set point is getting maintained through this sensor, and we are now release the vacuum system to self-regulating way. And vacuum has level decreased, and at vacuum level, operating level has decreased, in a sense, direct pump energy savings. Up to 10% has been, we have got. Some of our customer has resulted that. Moving to the next step, that is DIP. On efficiency DIP, that is optimizing the DIP quality at reduced cost. So what is the task of an operator in a DIP plant? His target, first target is to keep the quality, that is the brightness, ash, and in some cases dart speck. But what are the levers for him now? They are doing with some reject, high, low, or chemical dosing. So it is purely doing an experience basis, and they are managing the quality in somehow. So nobody is looking the cost part of it or how the cost is optimized. So here, what we are providing the solution to help their life better is, this is a data model on efficiency DIP that is taking care of your final quality with a main target object is to optimize the cost model or the cost function. That is the chemical cost, fiber cost, energy cost. Now, how this model will take care? It will be doing with actual field, you will adjust, automatically the model will adjust some of the field parameters. As you can see, the foam level for, say, for a DIP cell, as you can see, this is our normal cell, and physical, representation of this model, what we normally measure, this pump, this flotation pump energy, the savings I am talking about specifically today on this subject, that the pump speed will be regulating based on your actual need, and it is direct impact on the energy cost. So it will take care by its own. So what is happening inside? The amount of recirculation inside the cell is basically self-regulated doing now. So recirculation through one cell to another cell, which is earlier as a constant basis, now it is under what is just needed. In that way, there is a saving. And we have recorded that up to 30% of flotation pump energy can be saved. That is the situation before and after. Apart from energy, there are some chemical doses also reduction, 20% to 50% depending on different doses. Now the strength module. Strength module, as I told earlier, that it is basically related to optimizing the dosing, starch dosing. It is also the same. Maintain a target quality with such a multivariate things in a shop floor is really complex task to handle. And it is also coming with an other pain points as well, because there is no real-time sensor available to measure the targeted quality, let's say for strength. So for that, what are the pain points? There are no common sensors available. If you change some of the operating parameters, you have to wait till the next turn up. Lab will collect the sample, so 40 minutes, 45 minutes after you will see the change, in real world. And if in between you want, you have to make a break. So what it helping with a virtual sensor. So virtual sensors basically, in simple word, a mathematical model that will predict the target quality, let's say for strength, stiffness. So that will predict, and it will be integrated, with the APC for our final control on starch dosing. Now this is not an overnight task. It takes certain weeks to build the virtual sensors based on many data and running things. Now, when it's ready, now my quality parameters are available in real time. I can use simple another strength or on efficiency model that will taking care of the final quality in my final target with an optimization target on the cost part of it, and what are the levers, slice opening, J-to-A ratio, and starch dosing on the machine. Here is the result for packaging grade machines. So this gives a consistent quality requirements. Same strength quality has been achieved with a lesser starch application. That means steam energy can be saved in the after dry sections. For a copier grade machine, the example, the fiber is replaced. For the same GSM, fibers got replaced with, or you can increase the ash, which is again steam energy saved after dissections. Now moving to my last topic, on efficiency break protect, reduce breaks and increase productions. So what is today's state of the art break analysis are available? We have this is available, many of companies are doing with web monitoring, but what it gives, it will give a breaks count at certain position. So it is like we have the symptoms of the disease, but we don't know the root cause of it. So what we are providing here, or we are making it one step more, one step further, with our vast understanding of paper making, to analyze even one row in what are the root cause hidden inside it. And that has been also done through an AI-driven model that if you are interested, you can study its SDE, stochastic difference equations. So that model ultimately predict, or it will tell the operators that you have a risk of break due to this. You can take some corrective measures. Now it is not yet, we have made it auto so that that model itself take over the control. So it is still open for the operators. Operators finally change those in machine. So this is the way. It is always give a probabilistic model. It will tell percentage of risk associated with some certain parameters that there is a break could be with certain percentage of risk. So break prevention modules allows to understand the underlying root cause, the illness, and cure it sustainably forever. And as this is a result, before and after installing this module, there is a number of breaks and cumulative hours of the breaks has been reduced. So this is a summation, the summary of all and the savings potential what we have got. Now, with this, I want to invite or request all the paper community to embrace the digitalizations and move towards a greener future with a pledge. Let's make our world better with paper. Let's make paper better with papermaking 4.0. That is for 4. Thank you.